Hey everybody, it's Mr. Mott. What I want to do is go through how to balance these oxidation reduction reactions using the half reaction method, both in an acidic and a basic environment. So we're first going to approach this problem in terms of an acidic environment. And in the half reaction method, first of all, you don't have all the information. You don't have the entire reaction. And so that's an important piece to understand. And moreover, you're probably going to be asked to solve these problems in a specific way. So in the half reaction method, what we do is we sort of take our reaction that we have and we split it in half. And so we first take, for instance, the MnO4, and we switch pens here, and we look at how to balance the manganese, what's going on with manganese. So I'm going to take the MnO4 minus, and that's turning into MnO2. And then I'm going to look at what's going on with the other reactants, and I'm going to look at ClO2 minus going into ClO4 minus. And so this is the half reaction method, sort of isolating what's going on with manganese, what's going on with chlorine. And hopefully you could realize at this point you wouldn't really be able to balance anything, because as soon as you increase the things on your reactant side, the product side would need to increase as well, and you'll never be able to balance it that way. So the first thing that you have to do is add, to balance the oxygens, is add waters to each side. So I'm going to add some waters, and so for my top equation, I'm going to add waters to the right-hand side because I need to increase the oxygens there. Now, by adding one water, I only have 3 oxygens total, so I'm going to add 2 waters to the right-hand side. Okay, and I'm going to do the same thing for my reaction on the bottom, as I'm going to add some waters to it. So I'm going to add 2 waters on the left-hand side as well. Okay, so now that I've added my waters to balance the oxygens, I need to balance my hydrogens by adding the hydrogen ion, H pluses, to each side. So let me switch colors. And so on the top reaction, I've got 4 hydrogens on the right-hand side, on the product side. So I'm going to add 4 hydrogens here. And on the bottom one, very similar, adding 4 hydrogens here as well. So, so far, what we've done is we've looked at balancing out the oxygens and the hydrogens. Now we need to balance out the charge. And to do that, we're going to be adding electrons. And so we take a look at the charge component, and we notice that on the product side here, nothing has a charge. So that's a 0 charge. So we want to make sure that the reactant side also has a 0 charge. And so looking at, we have the MnO4 with a 1 minus, and we have 4 H pluses, so positive 4 in essence. So positive 4, negative 1, that means that we have a total of positive 3. So what we're going to do then is add electrons, and so I need to add 3 electrons to the left-hand side. So then, so now I have a total of 0 charge on the left-hand side, and then the 0 charge on the right-hand side. And so they don't always have to add up to 0, but they have to be the same on each side. Okay. Looking at a similar situation on the second equation, I have a total of negative 1, just really coming from my 1 ClO2 minus, and then I have a total of positive 3 here. So what I need to do then is add electrons to the right-hand side, so that this side, the product side, adds up to the negative 1 that we saw here. So to do that, think about how many electrons we would need to add. So we would have to add, we want to get to negative 1, so I'm going to have to add, so what happens if I add, we'd have to add 4 electrons. So in essence, what's happening is that these are canceling out, and then we have a negative 1 equal to the negative 1. So we're all good there. Now, similar to the oxidation number method, we have to balance out the charges using, we have to make the, well, we shouldn't not necessarily balance out the charges, but what we need to do is make the electrons that are being gained, which is 3, equal to the electrons that are lost. So similarly, we have to use a least common multiple like we did in the oxidation number method. So between 3 and 4, that least common multiple is 12. Okay, so then let's pick another color. So we're going to have to multiply everything by 4 here at the top. And we're going to have to multiply everything down here by 3. So what we're going to end up having is 12 electrons that are being gained, 12 electrons that are being lost. And so if we sort of carry out and distribute that value, let's kind of write down below here what we would get. Okay, so I would have my 12 electrons, and then I'd have 4 times 4 is 16 H plus, 4 times my 1 MnO4 minus. I'm going to have 4 MnO2 plus 4 times 2 is 8 waters. Okay, that's my top equation with the 4 distributing. On the bottom equation is my 6 waters. I'd have my 3 ClO2 minus. I'd have my 3 ClO4 minus, my 12H plus, and then I would have my 12 electrons. Okay. Now what we're going to do is add those up. And when we add those up, we can cancel out the things that are going to cancel. And some of it we can see right away, things that are going to cancel. And so my 12 electrons on the left-hand side and the right-hand side, those are going to cancel. And then we can see is that other things are going to cancel as well. I got my 16H plus on the left-hand side and 12 here. So all 12 of these are going to go away. So the electrons go away. 12 of my hydrogen ions go away. I'm going to subtract 12 from my 16, and I'm going to end up with 4H plus here. Okay. I only have MnO4 on one side, so that's going to drop down. MnO4 minus. Some of my waters, and then on the product side, well, let's continue to look on the left-hand side. My waters, a lot of times waters are on both sides, so 6 waters and 8 waters. Well, the 6 is going to go away, and this I'm going to end up with 2 waters on the product side there. I'm going to have we already did my MnO4, and on the left-hand side, I'm going to have my 3 ClO2 minuses. On the product side, at the top, I have my MnO4s, MnO2s, and then I have my 3 ClO4 minuses. Okay. So this is what we would have as far as our reaction left over, and this is done in an acidic environment. Okay. Now, I follow the same procedure. If I was to solve this and we were told that it was in a basic environment, then I would actually follow the same procedure as I just did. And then what we would do to make it in a basic environment is that I would neutralize all of the hydrogen ions that I have left over with hydroxide, that being in base, and I would add hydroxides to each side. So currently, this is my reaction here in the acidic environment. Okay, so I'm going to copy that, and then this would be, and I'll just draw kind of a line. If I was doing this in a basic environment, this is what I would do. Get rid of that dot. All right, so again, my reaction here at the top is acidic. Now I'm going to do this in terms of if it was a basic environment. Okay. So in a basic environment, what I would do is I would add in hydroxides to each side. So what I want to basically do is cancel out my hydrogen ions. So I'm going to add 4 hydroxides. And algebraically, if I'm going to do that on the left-hand side, I'm going to do that on the right-hand side. I'm going to have my 4 hydroxides added over here. So these are going to add up to 4 waters on the left-hand side, and everything else is going to remain. Okay. So what I'm going to do is I'm going to rewrite. I'm going to rewrite this and showing my new equation there if it's basic. Okay. So I have my 4 waters. I have my 4MnO4 minus, my permanganate ion, my 3ClO2 minus. I have my 2 waters. I have my 4MnO2. I have my 3ClO4 minus, and I have my 4 hydroxides. Woo! Now, we're not quite done here because, as you might have sort of seen as we went through, we've got waters on both sides of the reaction. Okay, so what we're going to do is we're going to cancel some of those out because I've got waters here and I've got waters here. So algebraically, if this is 4x and on the left-hand side, 2x on the right, the 2x's cancel, this 4 becomes a 2. So what we end up having as our overall reaction now is 2H2O plus 4MnO4 minus plus 3ClO2 minus, and you have 4MnO2 plus 3ClO4 minus and 4 hydroxides. And this would be your answer in a basic environment. So the way that I approach these is if it's basic, if it's acidic, I solve it in the same way that we did, in the beginning. If it's basic, I solve it in the same way. I just cancel out my hydrogen ions in the end by adding hydroxides to both sides, and then I simplify. This method's a little bit different than what's in your book, but I think it's pretty effective, and if I can sort of learn one way to approach all these rather than 2 different ways, then it's a little bit easier for me. So I hopefully that helped you, and good luck balancing your redox reactions.